All right, in this lesson, we are going to solve 3x3 systems using substitution. So 3x3 systems means 3 equations, 3 variables. Okay, and so here you see 3 variables and 3 equations. And so to do that, we're going to use the substitution method. There is an elimination method, but today we're just talking about substitution method. So we're going to review substitution method on a 2x2 system because that will translate to what we are doing with the 3x3 systems. So for the substitution method, you need a variable already solved for. And so when you're solving for a variable, look for a variable that doesn't have a coefficient other than 1. That's going to be the easiest one to solve for. And so here's equation 1 and equation 2. I'm going to use equation 2 to solve for x. Okay, and so to solve for x, we need to move the 14y to the other side, and that becomes negative when we move it over. And so now it's 10 minus 14y. Okay, and so once you have one variable already solved for, I like to make a column and write the other equation, which is equation 1. So equation 1 says 3x minus 4y equals 7. And so x is the variable that we have solved for. So x is the variable we are substituting. I call him the player getting subbed out of the game. And his sub is 10 minus 14y. He's going in for x. And so your first thing is take x out of the game and leave a blank set of parentheses where he used to be. Write down the rest of your equation. And we're going to fill in the 10 minus 14y, his sub. Okay, and so from there we have an equation that only involves y's, and so we can solve for y by first distributing combining our like terms. Negative 42 and negative 4 is negative 46. And then to isolate y, we first need to subtract 30 from both sides. And then we would divide by the negative 46. Negative 23 over negative 46 is positive 1/2. So once you have y, go back to the first column where we had x solved for, and we are going to substitute that value for y. And so that's going to give us x. So 14 times 1/2 is 7, and so x equals 3. And so write your final answer as an ordered pair, 3, 1/2. Okay. So now we're going to work with 3 equations and 3 unknowns, but the process is very similar. The steps are written out here. And so what I like to do is number my equation. It just helps me stay organized. So I have equation 1, equation 2, and equation 3. And so we are going to pick one of the 3 equations, pick one, to isolate a variable, just like I isolated x up here. And so we're going to look for a coefficient of 1. And so I think equation 1, it would be easy to isolate x. So in that case, we need to move the rest to the other side. Okay, so equation 1, x equals, we would have a positive 6y on the other side, a positive 2z, and then a minus 8. Do your 2's with the loop, z's with the bar, so 2's don't look like z's and vice versa. Okay, so now that we've solved for x, he's the player getting subbed out of the game. And so under that, you're going to write equation 2 and equation 3 without the x. Okay, x is the player getting subbed out of the game. And so equation 2 would just be negative, parenthesis, plus the 5y, just copying it down, plus 3z equals 2. And equation 3x, you're going to need a bigger set of parentheses than that. So 3x minus 2y minus 4z equals 18. And in the blank parentheses where we took x out, we are filling in his sub, which is 6y plus 2z minus 8. 6y plus 2z minus 8. Okay, and so we've substituted the expression for x into both equations. And so now we need to simplify these. When you simplify these, there's still going to be two variables, and it's going to leave us with a 2x2 system, okay, with y and x only. So first step to simplify is distribute the negative, which would give me negative 6y minus 2z plus 8. Distributing a negative flips everybody's sign. Plus 5y plus 3z equals 2. Next, you're going to combine your like terms. And so I have a negative 6y and a 5y would give me negative 1y. And then I have a negative 2z plus 3z, which is just positive z plus z. And then you want to move the constant to the other side. Okay, and so minus 8 from both sides would give us a negative 6. You want it in standard form. Okay, and so I'm going to box this equation, and I'm going to call it equation 4. And we're going to do the same thing over here to get equation 5. So first step is distribute your 3. 18y plus 6z minus 24. Minus 2y minus 4z equals 18. I have an 18y minus 2y, which is 16y. I have a 6z minus 4z, which is 2z. And then we are going to move the constant to the other side to join the 8. So add the 24. And that would give us 42. Now, before you commit to this equation, if there's a GCF in all three places, go ahead and divide it. Simplify as much as possible. Keep the number small. Okay, and so I can divide each of those numbers by 2, which would leave me with 8y plus z equals 21. Okay, so that's what I'm going to use as my equation 5. Okay, and so once you have equation 4 and 5, they're going to join together to be a 2x2 system. And we're right back to what we did on the warm-up. Okay, and so from here you can use substitution or elimination. I'm going to keep using substitution just because these are the substitution notes. And so I am going to use equation 4 to solve for z, and that would require us to move the y to the other side. Okay, and so z equals y, positive y since we moved it, minus 6. So that's my new equation 4. And then equation 5, z is the player getting subbed out of the game. And so I'm going to write equation 5, and we are subbing the z. Okay, so that gives me 8y, and we are filling in the y minus 6 for z. There's nothing to distribute, so the parentheses aren't necessary. Technically, you're distributing a positive 1, which won't change anything. Combine your like terms, add your 6, So 9y equals 27. Divide by 9, and we get y equals 3. Okay, so we have y. Go back to equation 4 to get what z is. So if y equals 3, z is 3 minus 6. Z equals negative 3. Okay, and so you are going to take your y and your z, go all the way back to the very beginning where you solved for x, and you are going to substitute those values. Okay, so 6y plus 2z minus 8. But now we know z is negative 3. Make sure you put them in the right place. And we know y is 3. And so we get 18 minus 6 minus 8, which would be 4. Okay, and so x is 4, y is 3, and z is negative 3. Always write your solution as an ordered triple, x, y, z. If it's A, B, C, you still go in alphabetical order. Okay, and so x was 4, y was 3, negative 3. So this would be our final answer. Okay. Number 2 is similar. So let's look at, I want to look at number 5. So for number 5, we already have a variable solved for. It's the y. So when I number my equations, step 1 is done for us. Y is going to be the player getting subbed out of the game. Okay, and so I'm going to write equations 2 and equations 3 without the y. So equation 2 would be x plus 3, big set of parentheses, minus 3z equals 12. Just copying down this equation. Now I'm copying down this equation. Negative x plus 2y minus z equals 1. And so we are substituting the y with this expression, 3x plus 4z, 3x plus 4z. Clean them up by distributing. I get 9x plus 12z. 2's with a loop, z's with a bar. Minus 3z equals 12. Combine your like terms. I've got an x and a 9x, which would create a 10x. And then I have 12z minus 3z, which is 9z. And there's really nothing we can simplify here. So we're going to commit to that as our final answer, or our equation 4. For equation 3, distribute the 2. Combine your like terms. I've got negative x plus 6x, which is 5x. I've got 8z minus z, which is 7z, equals 1. Okay, and so there's nothing to simplify. And so that is our equation 5. So 4 and 5 become our 2x2 system. Now for this one, I'm going to switch back to elimination because the x's will cancel very nicely if I just multiply the bottom equation by negative 2. So I'm going to take the bottom equation and scale it by negative 2. to create a 0 pair in the x's. And so my new equation would be negative 10x minus 14z equals negative 2. And then I will write equation 4 right under it. X's cancel. Negative 14 plus 9 is negative 5. Negative 2 plus 12 is 10. Divide by negative 5. You get z equals negative 2. Okay, and so now pick either equation. I like this bottom equation better. 5x plus 7z equals 1. Just copying down this equation. But now we know z is negative 2. So that gives me 5x minus 14 equals 1. Add 14 to both sides, we get 5x equals 15. Divide by 5, we get x equals 3. Okay, and so now that we know z and x, we're going back to this step 1, and we are going to substitute those. So we have 3x plus 4z. Z was negative 2. And x was 3, which gives me 9 minus 8, which is 1. Okay, and so when we write our final answer, ordered triple, x, y, z, we have 3, 1, negative 2. Okay, let's look at number 3 and number 4. Okay, so for number 3, we have equations 1, 2, and 3. These are special cases, I believe. Yes. So I think the easiest variable to solve for would be this y, and we'll substitute it in the other 2 equations. So starting with equation 2, we're going to isolate the y. That means the 2x has to go to the other side, making it a negative 2x. And the negative 3y has to go to the other side to become a positive 3y. And then we have this 5 already there. Okay, and so we are going to copy down equations 1, because we haven't used it yet, and equations 3. Substituting, we're taking y out of the game. So for equation 1, I have a negative 4x plus 7y minus z equals 1. Copying this down without the y. And then now copying equation 3, I have 4x minus 7y plus z equals negative 1. Okay, and so y is equal to this expression, so negative 2x plus 3y plus 5, negative 2x plus 3y plus 5. Okay, now we're going to clean them up to get equations 4 and 5. So distribute this 7. Gives me negative 14x plus 21y plus 35 minus z equals 1. Collect our like terms. I've got a negative 4x and a negative 14x for negative 18x. And then I've got 21, I lost a y. No, I didn't. Negative 2x. So equation 2, we moved the x and moved the 3z. I'm sorry, that was a z. And so we can combine 21z minus z to get 20z. And then move your 35 to the other side. So minus 35 from both sides would be negative 34. Now these are some pretty ugly numbers. I notice they're all even, so we can at least divide them by 2, giving me negative 9x plus 10z equals negative 17. And so that will be my equation 4. Okay, over here we are distributing a negative 7, and that 3y should have been 3z. So 4x plus 14x minus 21z minus 35 plus z equals negative 1. Combining our like terms, I get 18x and negative 20z, add 35 equals 34. These are both even as well. Well, all three are even. So I can simplify to 9x minus 10z equals 17. That's my equation 5. Now, when I write my equation 4 and 5, my 2 by 2 system, I get negative 9x plus 10z equals negative 17. 9x minus 10z equals 17. And if you notice, when I add these equations together, the x's already cancel, but so do the z's. And so I'm left with a 0 on the left, and then on the right, I'm also left with a 0. So if that happens, if everything drops out and you're left with an equation that says 0 equals 0, that means you have infinitely many solutions. If I were to get like 0 equals 34 or something like that, that would be no solution. But if you have a true statement, it's infinitely many solutions. That means we have infinitely many points that would satisfy this system of inequalities. Okay, and so you can kind of recognize that if you look at equation 1 and equation 3, they're the same equation. One is just scaled by a negative. So sometimes it's obvious right off the bat, but not always. They're the same line. And so kind of like when you have two lines on top of each other with a 2 by 2 system, that's what's happening here, but it's in 3 dimensions. They're the exact same line. So you have infinitely many solutions on this line that would, infinitely many points that would be solutions. Okay, and so looking at number 4, this will be the last one we do. We've got 3 equations, and they're looking kind of ugly. And so a tip is simplify your equations by scaling them if you can. And so this top equation, I can divide all these numbers by 2. And that would give me P minus 3Q plus R equals 4. For the second equation, I have this denominator of 3. And so let's scale the entire equation by a 3 to clear those fractions. So equation 2 would become 3p plus 2q plus 1r equals 3. And then the last equation, once again, we can divide all of those by a 2. Okay, so negative 6p minus 4q minus 2r equals 1. Okay, so now we can pick a variable to solve for. I'm going to pick equation 1. P would be easy to solve for. Move the other terms to the other side and be careful doing that. That's easy to mess up. So 3q minus r, and then plus 4. And then write down equations 2 and equations 3 without p. Okay, and so 3p plus 2q plus r equals 3. Negative 6p minus 4q minus 2r equals 1. P is equal to 3q minus r plus 4, 3q minus r plus 4. Clean them up, so I get 9q minus 3r plus 12 plus 2q plus r equals 3. Combine your like terms. I've got 9q and 2q for 11q. I've got negative 3r and r for negative 2r. Subtract 12 equals negative 9. Nothing to simplify, so that's our equation 4. Clean up this, negative 18q plus 6r minus 24 minus 4q minus 2r equals 1. I've got negative 18q minus 4q, which is negative 22q. I've got 6r minus 2r, which is 4r. Add the 24, and we get a 25 on the other side. Can't simplify that either, so that will be our equation 5. So now when I write my 2x2 systems from 4 and 5, the q's will cancel by elimination if I multiply the top equation by 2. That would create a 0 pair in the q's. So my new equation would be 22q minus 4r, and then minus 18. And then when we add them, the r's also cancel. Q's cancel, r's cancel, leaving me with a 0. But on the right side, 25 minus 18 is 7. This is not true. And so we're going to say no solution. If it's true, infinitely many. If it's false, no solution.